Hello everyone, welcome to our channel Simplified Computer Science Concepts by Professor Rutuja. Today we will be learning Distributed Deadlock Prevention Algorithm. So, before starting with anything, let us first know what is Deadlock Prevention Algorithm. So obviously when we talk about prevention, this technique ensures that there is no deadlock by making it structurally impossible. Obviously it is a cautious approach, and whenever a site senses that there is a chance of deadlock, the transaction will either be aborted or it will be restarted. So here deadlock is never going to happen. So this technique requires no deadlock detection and recovery mechanisms. So there are two approaches for deadlock prevention. One is the non-preemptive approach and the other one is preemptive approach. So here wound and wait deadlock prevention algorithm is the first approach, and which is a preemptive method, and wait and die deadlock prevention algorithm is a non-preemptive method. So let us first going to this algorithm, first recall certain concepts of timestamp ordering of the events. So if you remember in the earlier lectures, we have seen that each event is assigned a particular timestamp, and that is in increasing order. So if there are two events, that is event 1 and event 2, event 1 has occurred first and event 2 has occurred later, then event 1 will have a smaller timestamp than that of the event 2, which means that event 1 has the higher priority than that of event 2. So obviously these timestamps are given in an increasing manner, and so earlier events will receive a smaller timestamp, and the events with the smaller timestamps will obviously have the higher priority. Now let us understand this wound wait deadlock prevention algorithm, which is a preemptive method. So there are two cases that we will be learning over here. The first case is when an older event is trying to access the resource that is held by the younger event. So there are two processes, P1 and P2. P1 is the older process which has a timestamp of 10, and P2 is the younger process which has a timestamp of 20. So obviously P1 is arrived first, and then P2 has arrived at timestamp 20. Now they share a resource. This resource, P2 holds this resource and P1 is requesting for this resource. So here what happens is that whenever an older process is requesting for a resource, and if that resource is held by the younger process, then the older process will preempt the younger process. That is why it is a preemptive approach. So here just map this concept to a real-time scenario wherein the younger people always respect the older people. In the similar manner, whenever an older process comes and requests for a resource which is held by the younger process, then at that immediate time, the older process will preempt the younger one, and that particular resource will be allocated to the older process. So here P1 will preempt P2, and that particular resource will be allocated to the older process, that is P1. So the older event will preempt the younger event. This was the first case. Now let us see the second case. That is vice versa. That means an younger event is trying to access the resource that is held by an older event. So here P2 is the younger event which is requesting for a resource that is held by the older process, that is P1. So here what happens? P2 has to wait till P1 releases the resources. So P2 will wait till P1 releases the resources. So again here the older card is played by the older processes. The P2 again says that let the older process complete, then I will get the resource and complete my task. So the younger event will wait until the lock is released by the older event. So this was wound wait deadlock prevention algorithm. Now let us go and check wait and die method, which is a non-preemptive method. Now again here there are two scenarios. The first scenario is when an older event is trying to access the resource that is held by the younger event. So there are two processes, P1 and P2. P1 is older process, P2 is younger process with timestamp 10 and 20 respectively. There is a resource that is shared. P2 holds the resource, P1 is requesting the resource. In this case, P1 will wait. The older event will wait as it is executed for longer period of time, which means that P1 has completed its execution for some amount of time. So, whenever the younger event will come, P1 will wait saying that younger event needs to proceed. Then the second case is that when a younger event is trying to access the resource that is held by an event that is older. So P2 is the younger process which is requesting the resource, and P1 is the older process which is holding that resource. So here P2 has just arrived, so P2 dies. So it dies for P1 because considering this in mind that P2 has arrived just and it has not invested lot of time for execution, and P1 being older one, it has maybe it is in the half of its execution. So deleting that would be costing a lot. That is why killing the younger processes would be beneficial. So that is why P2 will kill itself and P1 will continue with the execution. So the younger event will die or will be killed. So I hope you have understood this concept of deadlock prevention algorithms. Thank you for watching the video. Please do like, share and subscribe to the channel. And if you have any comments, please post in the comment box. Thank you.